This is lesson 27, Kinetic Molecular Theory and the Gas Laws. So Avogadro said that equal volumes of different gases contain equal numbers of particles at the same temperature and pressure. So the molar volume of a gas at STP, which stands for standard temperature and pressure, which is equal to 273 kelvins and 1 atmosphere, is 22.4 liters, meaning that a gas will take up 22.4 liters of space at this temperature and pressure. And kinetic molecular theory, which is just a bunch of assumptions that we make about gases, says that all gases are in constant random motion. Particles will move in straight lines until they collide with a container. Gases are mostly made up of empty space because the particles are so much smaller than the container that they're in. There are no intermolecular forces between gases, and collisions between gases or gases in the container are what we call perfectly elastic, meaning that they do not lose energy. And finally, the average energy of a gas depends only on the temperature of the gas. So the first gas law that can be described using kinetic molecular theory is Boyle's law, which says that at constant temperature, the pressure of a gas is inversely proportional to its volume. So Boyle's law is P1V1 equals P2V2. So as pressure goes up, volume must go down. Gay-Lussac's law says that at constant volume, the pressure of a gas is proportional to its temperature. So as pressure goes up, temperature goes up, and vice versa. Which makes sense because as the speed of the particles goes up, the temperature, they hit the walls of the container harder. So the pressure also goes up. And finally, Charles's law says that at constant pressure, the volume of a gas is proportional to its temperature, which makes sense. If you think of a balloon, when you take it outside in the cold, as the temperature goes down, the balloon shrinks up. And then as you bring it back inside, as the temperature goes up, the volume increases again. Because as the temperature increases, the particles move faster, which allows them to expand. So we can combine these three laws together to come up with the combined gas law, which is P1V1 over T1 equals P2V2 over T2.